Okay, welcome. Welcome to lecture here. We'll get started in just a sec, continuing on. All right, welcome to lecture. We'll get started here in just a sec, continuing on with chapter 2, I think. Again, please type here for the roll in the chat box. Move some stuff around here. There we go. Okay, we are in chapter 2, and we've been talking about significant figures, taking measurements, units, all that stuff last couple of times. We're going to continue on now talking about dimensional analysis, which is really conversion, doing conversion problems, and we will finish up with density. Before we get going, I just want to talk a little bit about sort of the pre-lab. I've been getting some emails about it and stuff like that. So I'm going to take a look at the pre-labs, the way they're set up. Again, as we talked about, they sort of try to make this class sort of the same for every section and stuff like that. So they kind of set up the pre-labs and sort of that organization of it. So I think what it's set right now is it's set at you got to get 100% to get to pass or fail. So again, if you just miss one little thing, it's going to knock you out as a fail on that because again, you miss something, you didn't get 100% exactly on the nose and stuff like that. So what we want to do is we want to make sure that you will get points for it, even if it says that you failed on it as to this point. I'm going to go look at it. Like I said, I'm going to probably adjust that little setting there so it's not so strict that you have to get 100% obviously on it and stuff like that. So I think in the end what's going to happen is you're just going to get whatever obviously point value that you get for that will be what you'll get obviously on the pre-labs and stuff like that. So don't freak out here on these first couple. I'm going to go back and, you know, that's sort of, I think, how the pre-labs are going to be. So I do think for some reason they set it at 100%. So, you know, if you just miss one little thing, it's going to knock you out as not passing and stuff like that. So in the end, like I said, you'll get whatever points you got on that, you know, in the sense of whatever it was worth and sort of what you got wrong and stuff like that, kind of like a normal sort of assignment. So give me a day or so and I'm going to go in there and kind of double check that setting. But based on the emails I've been getting, that would be my best guess that that's sort of how it's set at, like, you got to know 100% to get points and stuff like that. So again, even on these first ones that you maybe have completed, if you says you failed and you just missed one thing or something like that, again, you're not going to get a 0 on it or anything like that. You will get obviously whatever points it will come to. All right, so hopefully I think that was the majority of sort of emails I was getting, in that they've over the years sort of set them different ways, 85%, 90%. Some people have set it to 100%, so that. Okay, so if it does give you that option to kind of redo it, you can. But I think just to make it better, I'm just going to reassess it. And I'm going to probably change it so that, you get kind of what you get and stuff like that. You'll still have probably a couple opportunities on the questions and stuff like that to, get the questions correct and stuff like that. All right, we are, again, off to chapter 2 here. And we will continue on. If you do have questions, feel free to ask them and stuff like that. Again, also a reminder, since we're talking kind of about the online homework as well, in each of the week's modules, there is, the chapters homework sort of listed. And again, they're just there really to sort of remind you to stay on track with those so you don't wait to the last minute. Again, as we talked about on the first day and everything, the actual homework for those chapters, the due dates is reflective of when the exams will be. So they are due on pretty much the day of the exam. But again, they're in each of the modules just to kind of remind you to, keep on track with that and everything in that sense. Yeah. Other questions or anything like that? Okay. So for example, I think our first exam is the 21st of September. I have that date in my head for some reason. So somewhere in that ballpark or somewhere around there, or whenever it is. Again, all those chapters for that exam will be due on that day. But again, they're just sort of reminders that don't wait till last minute. Try to keep on pace with those things. All right. Now let's get cranking, hopefully, here. Move a couple of things so I can see. It would be good, probably. I'm assuming. Okay, so last time we talked really about, again, measurements, significant figures. Remember that when we do take a measurement, it's really important to look at the scale of the equipment that you're using. Make sure that you figure out what the smallest markings mean in terms of their value. And in most cases, as we talked about, you essentially can go one more place to the right of the smallest marking. So we did some examples when we were talking about it. But for example, if you were looking at a ruler and each of the smallest markings was 0.1 centimeter, for example, you typically could take the reading to one more place to the right, which would be obviously the second decimal place. And again, it's that sort of estimation that you do that basically makes our significant figures. So when we do take a measurement, we always want to record all the certain numbers plus that first uncertain number. And again, that is what basically encompasses significant figures. So, you know, if you recorded 1.35 centimeters, that would have 3 significant figures, where the 1 and the 3 would be the certain numbers, the 5 would be the uncertain number. Remember that you can also figure out sort of the precision of the equipment by taking the smallest marking and dividing it by 2. You know, so for example, if the smallest marking was 0.1, and you divided it by 2 there, you have your precision to 0.05, also gives you sort of that, how far you could take the reading to. Remember that you do want to record all those things, and you should never let go of a digit in terms of significant figures, because again, if you do sort of drop off a significant figure that should be there, what you're doing is really making your measurement a lot worse, like we talked about. So again, instead of the uncertainty being, you know, let's say you took that reading and you're like, hey, I think it's 1.3, and it's really, you should take the reading to 1.30, and you go, that 0 is not important. And again, as we talked about, when you would record this number, say if this was centimeters, the uncertain digit or the estimated digit would be here, which means, again, it could be like 1.4, it could be like 1.2. While because you do have the ability to record that last little digit there, the uncertainty would lie here, as this guy would have 3 significant figures. And again, it means that really, you know, your measurement could be something like that, 1.31 or maybe 1.29. Much better measurement than, say, this one here, much more uncertainty in this measurement. And obviously, you have the ability to do that, and you should record all those digits. Again, even if you feel it's dead on a line, you should maintain that 0 if you can at that particular place. Again, otherwise, you're really making the measurement very, very bad. And not really taking a correct measurement, because you're implying the uncertainty obviously is one more digit over to the left, which again doesn't make it as a good measurement as it should be. We also talk about significant figures really in terms of calculations, and remember that there's really 2 types of calculations. There's multiplying and dividing, so that group of calculations, when we multiply or divide, what we're looking for is the significant figures, and the number with the least number of significant figures is how many significant figures your answer should have. While if we add and subtract, what we're looking at is decimal places. So not significant figures, but actually decimal places. And again, same idea here. The smallest number of decimal places is how many decimal places your answer should have. And a reminder that although it may have a certain number of decimal places, that means that it may not be the same number of significant figures, right? So significant figures and decimal places different. And again, we're looking at decimal places with adding and subtracting. Again, if you're doing multiple steps along the way, you do want to keep track of everything, and you do want to kind of do it in the mathematical order like you normally would do. So, you know, if you are multiplying first, you want to get to the right number of sig figs, and then if you're dividing, also sig figs as well. Yeah, so I think that might have been your question you just asked there, but yeah, so you want to basically just keep track of it. So again, in the order of the math operation, you want to keep track of it. So for example, let's say you were adding first 1.2 plus, you know, 1.00, and then you're going to multiply it by 3.33. Forget about what the answer may be, but the first thing you would do is probably add these two together, which means you would be looking at decimal places, and that means that would give you 2.20. Again, because this has one decimal place, you really shouldn't record this 0, and this should become 2.2. Then technically you would be taking the 2.2 and timesing it by 3.33. And since now we're multiplying here, we would be looking at significant figures. This guy has 2 sig figs. This guy has 3 sig figs up here, which means your answer should end up with 2 significant figures. So again, if you're kind of doing multiple steps, multiple sort of operations, you want to keep track of it. And again, kind of clean it up at the end. As we also talked about, you usually don't want to round too much if you're continuing on with the number. Again, they talk about guard digits. I guess you could do that if you like. But, you know, just try not to round too much into the very end and kind of clean it up. But definitely just going to want to follow the normal math order, and whatever sort of is the last sort of process that you do, that's what you want to follow. Other questions on that? Okay, so then let's get into dimensional analysis. Dimensional analysis is really a fancy word for doing conversion problems, but it's a process and a technique that you do have to do, especially in chemistry, and they do expect you to do calculations using dimensional analysis, especially as you continue on, Chem 1A, Chem 1B, whatever Chem you're taking there along the way. So basically what dimensional analysis is we use really equalities. So equalities are really two things that are on different units, but does represent the same amount of something. So for example, if I had 100 pennies, that is the same as $1, right? So this is what is known really as an equality. There are two things, represents the same amount, but are in two different units. Obviously, we know we could pay in pennies, right? We could pay in dollars. You could go through the drive-through and, you know, empty out all the pennies, right, to pay. Or you could use dollar bills. Probably they'll put your picture up there if you keep paying with pennies and stuff like that. But technically, it's all really money, and it all represents the same amount. And really, from any equality that we can have, we could write really two conversion factors. And conversion factors are really just fractions, right? We could say 100 pennies over $1 as one conversion factor, or we could say $1 on top is 100 pennies, right? So what we really do when we sort of do dimensional analysis is it is really important to use your units, and you want to set it up so that the units really do cancel. You can see what units cancel, what units are still there. And, you know, obviously you always want to make sure does, you know, your answer makes sense when it's all said and done. So for example here, okay, let's get here, there we go. You know, when we do dimensional analysis, the way you want to set up, say you had, you know, 700 pennies. You know, how many dollars is that? And it's very sort of simple example, perhaps. So what you would want to do again is figure out your equality, which is your 100 pennies in this example, like we had before, is $1. And again, that gives you our two conversion factors that we just saw. And remember that you won't use both conversion factors in a problem. you basically want to use whichever one sort of makes sense. So what we would start with is 700 pennies. And the way you want to set this up is, again, even though this is really not a fraction, it is sort of a fraction. It's basically over 1, which means the units of pennies are on top. And when we want to get rid of units, we always want to put the same unit in the opposite location, which means we essentially want to put the pennies on the bottom, which means when we look at our conversion factor, we want to use the guy over here on the right to do that. That means that $1 would go up on top and 100 pennies would go on the bottom. So always opposite, and this is the way that you do need to show calculations and dimensional analysis. It is a skill that, again, they want you to learn here in chemistry along the way. And what we're going to do mathematically here is we're going to multiply everything on the top and divide by everything on the bottom. So we take 700 times 1 and divide it by 100. And that would give me 7, and the units would be dollars. We'll talk about a couple of things in just a sec. But in terms of the units, the pennies on top and the pennies on the bottom will cancel each other out. It's the same as going like 2 divided by 2 equals 1. If you have pennies on top in terms of units and pennies on the bottom, they also cancel out and basically become 1 as well. Now, when we do this, if you remember, something that's an equality is essentially considered an exact number, which means when we do calculations that involve equalities, we pretty much don't have to worry about significant figures with those equalities. So we essentially ignore them. And that's because, as we talked about last time, something that's an exact number, which is either a definition or something that's counted, can have an infinity amount of significant figures. So when we do calculations involving those things, we do not include them in the calculations. So what that means is the only number in terms of significant figures in my example here that we would have to look at would be this number here. Now this number here, because I did write a decimal point right there, you should hopefully know from our conversations last time that this should now actually have 3 significant figures, which means when I get to my answer, it should also have 3 significant figures. The way I just wrote it right here is 1 sig fig, right? So this technically in terms of significant figures would not be the correct answer. So you may say to yourself, well, what happens if I just go 7, put some zeros in there, right? And in this case, we do have 3 significant figures, right? So that's one way that you could do it. You could also do scientific notation, which, you know, you wouldn't want to do because you can't do that because it is a number between 1 and 10. So this would be our correct answer there. So that would give you 3 significant figures. And again, the proper way to do that because I put that decimal there. So in most cases, if you're doing some type of dimensional analysis problem, usually the number that you start with, like in this case, the 700, is probably the right number of significant figures that you should have at the end. And that's because in most cases, when we're doing dimensional analysis, we're essentially only doing multiplication and division, which means you should end up with probably the same number of sig figs as that original number. I would say probably 99 times out of 100, you're probably going to be good in terms of sig figs by going that way. Again, kind of a simple example here, but we do want to always show dimensional analysis. The idea here is unit A, and end up with unit B. Again, this is why units are really important when you're doing these calculations. So you can see the units, you can see which ones cancel, you can see which ones do not cancel. All right. So here are some common equalities that you sometimes come across. Again, we see, 12 inches is 1 foot. 3 feet is 1 yard. So those are the US sort of equalities there. On the left, in the center is the metric one. And then on the right there is going from metric to US. As we talked about, for our purposes in this class, any type of equality like you see on the screen here, we will consider an exact number. As I might have mentioned last time, sometimes when people cross over this way here, as you go metric to US or US to metric conversions, sometimes people do look at the significant figures. But even for us here, and I think in most classes here, we just kind of think of them as sort of exact numbers and not have to worry about it in terms of that. Again, some of these you definitely should know. This one I think was on a slide. This one comes across a lot. Feet a mile comes up a lot. And again, I don't know if this is, this might not have been in your slides, but you do have a similar table, I think, in your book, with these guys here as well. So again, the 1,000 and a 100,000 milliliters comes up a lot. Grams, milligrams, grams, and kilograms. And these guys, again, these with checks, they really do come up a lot. And as we talked about as well, they do want you to start learning these and sort of having this knowledge as you continue on with the rest of your chemistry classes here at Saddleback. So again, make sure that you do know these. Some things obviously you should hopefully know, right? Like these guys here, as odd as it may sound, people screw up on the time part of it. They go, hey, there's 60 seconds in a minute, there's 60 minutes in an hour. And then, when they go from hours to days, they do these 60 hours in a day, which seems like way too many hours. So hopefully you should have some of that knowledge, and you definitely obviously should know hopefully those things. But that's a common mistake that sometimes people will make. All right, so here, if we look at one here, a golfer putted a golf ball 6.8 feet across a green. How many inches excuse me, does this represent? To convert from one to next, again, we want to look for our equality. So in this case, we want to go from feet to inches. So 12 inches to 1 foot. Again, from that, we can write our 2 conversion factors, which are just fractions, really. 1 foot over 12 inches or 12 inches over 1 foot. So obviously here, the idea is we're starting with feet. We want to end up in inches. So feet need to be on the bottom. Again, opposites so they can cancel. Inches need to be on top there to be left with. So as we will see here shortly, we do want to use our 12 inches over 1 foot. So again, doing our calculation here, whoops, our feet are going to cancel. And again, math-wise, what we're doing, we're multiplying on the top here. We're going to then come back and divide by the bottom. So we're multiplying and then divide, yeah. Now let's talk a little bit about this, and we'll continue on here and see the answer, obviously, and this not too hard of a one. When you're doing multiple conversions or using multiple conversion factors, again, in terms of your calculator, sometimes people really mess up on that part as well. In terms of the multiplying part, you can multiply as many numbers as you like all the way across. When you're done, you should hit equals. And then if you have a number of things to divide by, people oftentimes will mess up by trying to put all those numbers in at once in their calculator. What you want to do is divide by the first number, hit equals, divide by the next number, hit equals, divide by the next number, hit equals, however many times you have that. And you usually will always get the right answer. Again, sometimes people want to punch everything into their calculator all at once. And if you don't put those parentheses in correctly, you will get the wrong answer in this particular case. So here we would take 6.8 times 12, technically divide it by 1. And what we would end up is 82 inches. Again, here, when we look at sig figs in terms of our answer, this is going to be considered an exact number, so we're not going to worry about it. So again, defaulting back to our original number here, this has 2 significant figures. And again, here we're looking for 2 significant figures here on our answer when we get it there. Any questions on that example there? And again, you do have to show, if you want all the points on stuff, you do need to show the work and the setup like this, both in lab, exams, quizzes. You do need to use dimensional analysis when you do it. Again, it is technically a technique or a skill that you do need to learn here. Any questions on any of that there? That one. Okay. So again, just looking at one more example here. Here we have 4.5 pounds. We want to know what is the mass in grams. So again, we could use our equality here, which is going to give us our two conversion factors, which is 1 pound is 453.6 grams. Or again, you could do the 453.6 grams over a pound. This is definitely, again, a conversion factor that you do need to know. And in this case, since we are starting with pounds, we want to get rid of pounds. So opposite location, we are going to use our conversion factor here on the right to do that. And again, putting it in here, we will see that our pounds will cancel. And again, we're going to multiply the top, which is 4.5 times 453.6, and then technically come back and divide by 1. And again, in terms of significant figures, because this is an exact number here, we're not going to worry about it. So as I mentioned before, almost pretty, I won't say 100% safe because nothing's 100%, but pretty darn close to looking at that first number there in terms of the significant figures. We have 3 significant figures, and our answer should end up with 3 significant figures. So when we do this on your calculator, 4.5 times 453.6, you do get this number here that gets spit out on your calculator, 2041.2. Again, looking at 3 significant figures does take us to here. So you do have 2 ways. One way, again, is you can use scientific notation like they did there. This going 1, 2, and 3 places to the left, which is where that comes from. Again, when we write something in scientific notation, all the numbers before the times 10 part is significant. So this would have 3 significant figures. You could also have done this, like so. This would also be 3 significant figures. No decimal point here, which means this last 0 is not significant. Also maintains really the meaning of the number 2040. Again, same thing here is what this number is as well. So as we talked about last time, you can use scientific notation if you like on everything. You don't necessarily have to use scientific notation. And again, in some cases, the only way to get the answer right is to use scientific notation in terms of significant figures. But if you want, you don't necessarily have to do it. You can do it kind of in decimal form if you want. Again, you just got to hit that right sig figs when it's all said and done. Any questions on that calculation there? And again, you need to get into the habit of showing this setup like that with the units canceling when you're doing these calculations. That is technically in most chemistry classes what is referred to as work. Yeah, so you need to make sure that you show those things. Okay. I kind of scribbled over it, but it's talking about you could keep a guard digit. And again, that's up to you if you want to do the guard digit. And again, what the guard digit is when you see those little lines that I kind of wrote apart. We do that guard digit, or if you're doing multiple steps in a calculation, just don't round too much. You can keep a few digits, it's okay. But again, you do want to keep in mind where you should end up when it's all said and done. All right, so why don't you try this one, take a minute or so here and figure out how many inches are in a yard. I'll give you some equalities in case you don't remember on the previous slide. There's 1 yard is 3 feet, and you hopefully should know the rest. So take a minute or so and do it, then we'll talk about it. Okay, so let's take a look. So again, 1 yard to feet is one sort of conversion, and then obviously in a foot, there should be 12 inches. Again, these are our qualities, and each of these we could write two conversion factors. Again, for example, we could go 1 yard over 3 feet, or we could do 3 feet over 1 yard. And here, since we are starting with 3.46 yards, we do want to convert the yards into feet. So again, opposite is what we're looking for here. So we want to use this where the yard is on the bottom so that it cancels, and 3 feet are on top. Again, if we just stop in terms of units, the yards will cancel. We will be left with feet on top. Now you do have an option here. This is not what we're looking for in terms of an answer. But you could get an answer at this point, or you could just continue on with the conversion. So I'm going to continue on. So I'm going to go now from feet to inches. Again, by writing it like this and showing the dimensional analysis, we could see that our feet are on top, which tells us opposite of that, the feet need to go on the bottom and the 12 inches need to go on top. The feet now will cancel. And if we're multiplying here, we're going to multiply everybody on the top. We're going to take 3.46 times 3 times 12. So we're just going to keep multiplying here and here. And if we do that, 3.46 times 3 times 12 hit equals, we get 124.56 inches is the only units left. We technically divided by 1. I didn't punch it in because obviously you get the same answer, but we would go back if there were numbers on the bottom and divide by the first number, divide by the second number. Now, in terms of significant figures, this again is an equality, so we'll consider an exact number. This also same deal, which as we talked about before, pretty much takes us back to our original number, which has 3 significant figures. This means over here, we should end up with 3 significant figures. That takes us technically to here. We then want to look at this number, which on my calculator is a 5. And that means that you would most likely want to round to 125 inches. Or again, you could use scientific notation, 1.25 times 10 to the 2 inches as well. So that again is either way you could do it. Now, if you wanted to, you could get an answer. So you could have done 3.46 and times it by 3, and you would have got, here in this first step, 10.38, and at that point it would have been feet, and then continued on with your 12 inches is 1 foot in this case. Again, here, as you can see, even though technically this number here should have been 3 significant figures, I did not round, or I would not round at that point, and I would continue on until we did get obviously to the final answer, which is over here, right? Final answer. Any questions on that? So you do need to again show all this work here, the setup and all that good stuff, for the points. You don't have to necessarily show, the equalities or the conversion factors. If it helps you to do that, you can. But, you basically do need to show the dimensional analysis part, the setup with the units and all that. Any questions on that one? Okay. So here's the metric system, right? And we talked about the metric system. We also talked about conversions and converting from one to the next. So this is sort of our another sort of version of what we saw earlier. We saw like 10 to the 3, for kilo, 10 to the minus 3 for centi and all that kind of stuff. So again, when we do this, we can use these as conversion factors. Remember though, again, this is sort of half of that version there, but for example, kilo was 10 to the 3 on that other chart that we saw. And as we talked about, for example, if we're doing grams, that would mean in 1 kilogram, there's 10 to the 3 grams. In terms of say centi, right, it's like 10 to the minus 2. So again, in 1 centigram, there would be 10 to the minus 2 grams, or 100 centigrams in a gram. If you divide it out, if you take 1 divided by 10 to the minus 2. So again, these are the same sort of conversions that we saw earlier. And as we talked about, people oftentimes will kind of do these things backwards. So you want to really watch out for that. Now, when we're starting in the metric system, if you're starting in the metric system, it will only take you usually 2 conversions to do those. So why don't you try some of those there? Take a couple minutes here and do these conversions. Again, when you're doing the conversions, do them as dimensional analysis problems. So show the units canceling and do those. So take a couple minutes here and run through these and see what you come up with. Okay, so let's see how we're doing on these. So again, there's a couple different ways you do this. A lot of times those tables will have those sort of prefixes, kilo, like, 10 to the 3 and that. So I'm going to sort of do the calculation showing you that way. Again, like you could convert it into 100 centimeters as a meter and that type of stuff. But I'm going to show you the other way because, again, that's where a lot of people will really kind of make mistakes and stuff like that. So here we're going from kilograms to grams. So remember, as we talked about, this is sort of the prefix unit, right? And this is our base unit, right? So our base unit is grams in this case. And again, if you went to one of those tables, or again, you do need to sort of memorize these guys at some point, you would look up kilo, and again, it would say 10 to the 3. And what that means when you go to that table is, in this case, since we're looking at kilograms and grams, that there is in 1 kilogram, 10 to the 3 grams, which again is an equality and can use it just like a conversion factor. You can write 2 of them for it. So here we're going to start with 25 kilograms. We want to get rid of the kilograms, so we're going to put the kilograms on the bottom. 1 kilogram is 10 to the 3 grams, or 1,000 grams, right? And again, you could do 1,000 grams over a kilogram, same deal. Again, here, dimensional analysis, our kilograms are going to cancel. Grams are going to be left. So we're basically taking 25 times 1 times 10 to the 3. And if you do that, you will get 25,000 grams. Now, in terms of significant figures, again, an exact number here, so we're not going to worry about it. Coming back to our original number, 2 significant figures, which means our answer should have 2 significant figures. And it does based on how I wrote it. No decimals in there, so none of the zeros at the end are significant. You could do 2.5 times 10 to the 1, 2, 3, 4 grams as well. Again, 2 significant figures on that if you want to write it that way. Any questions on that one? So again, here as well, we're going to look at decigrams and grams. So if you go to that table, or if you know what deci is, when you look up deci there, it says deci is 10 to the minus 1. So again, our base unit is grams. So what that means is in 1 decigram, there is 10 to the minus 1 grams. Again, you could use it as 2 conversion factors as well. So we'll start with our 75 decigrams. Again, decigrams are on top, so we want to get rid of them. So on the bottom would go 1 decigram. On top would go 10 to the minus 1 grams. Or that's the same as 10 decigrams in 1 gram. So either way, however you want to do it. Again, here our decigrams will cancel. We're basically multiplying 75 times 1 to the minus 1. And that gets us 7.5 grams in this particular case. And again, that's the same thing you would get if you did the 10 decigrams as 1 gram, and you get the same. And everybody understands what I'm saying. You could change that out by taking 10 to the minus 1 divided by both sides. And that would give you 10 decigrams is 1 gram. So again, sometimes people will use the more whole number version of it because it's maybe easier, or some people will use sort of the exponent version of the conversion. They're both the same. And it's okay to use either one, whichever one you're more comfortable remembering. You can kind of do it that way.
Hey, I got a question.
Yeah.
So for number 1,
yeah,
when you converted it to scientific notation,
yeah,
how do you get it to be 2.5? How do you do that?
So remember, when you do write it in scientific notation, it needs to be a number between 1 and 10, which means the decimal point technically would be here, even though it's not written. We go 1, that would be still in the thousands, right? 2, 3, and we have to go all the way 4 places to get to a number that's 2.5, which gives us a number between 1 and 10. Again, this part of the number in scientific notation is how many significant figures there are. So since we're looking for only 2, we left it at 2.5. We dropped off the last zeros.
Okay.
Because if we left the zeros in there and did like 2.500 or something like that, it would still be the same value, but in terms of significant figures, it would have like 4, for example, if you did 2.500 times 10.
Okay.
Yeah.
Thank you.
Question? You're welcome. Other questions or anything? Okay. So here we're actually going from prefix to prefix, and this is also a place where a lot of people will mess up on because they will try to move the decimal places the right number of ways. And to be honest with you, I can't do it myself off the top of my head, figuring out, I know there's a song I think you could sing to figure out which way you need to go and how many places to move it. So whenever you're going from, say, one prefix unit to the next, it's always a good idea to take the first prefix unit to the base unit and then go from the base unit to the next prefix unit. And the reason for that is, again, you will know it by heart or memorize it, but you pretty much will know all these sort of conversions, which means as long as you could get it to the base unit, you could go from one conversion to the next. So if we did that for this last one here, the idea would be the first thing we'd probably want to do is take it from kilograms back to grams, which is our base unit. And then we could pretty easily find the conversion from going from grams to milligrams in that case. And that's always a very good way of doing that, is always just take it back to the base unit, because you could find that conversion and then take it from the base unit to the next prefix. So doing that, we're going to need our kilo guy that we did before. So we're going to start with this part of the conversion. So we're going to take our 125 kilograms. We're going to use that equality like we did before. We want our kilograms on the bottom. 1 kilogram is 10 to the 3 grams. So again, if I stop the calculation right at this point, I am now in the units of grams. You could get an answer if you wanted to. You don't necessarily have to, or you could continue on. I'm going to continue on, and now I'm in grams, and I want to go from now grams to milligrams. And the benefit of doing this is you can easily sort of find that conversion. So again, if you go to that table like we've been using, you will see that milli is 10 to the minus 3. So when we have milli, it is 10 to the minus 3. What that means again is in 1 milligram, there is 10 to the minus 3 grams. So again, oftentimes backwardsly done by people. Now, when we continue on with our calculation, our units are important. Our unit of grams on top, so we want grams on the bottom. So 10 to the minus 3 grams on the bottom, and that's going to give us 1 milligram on top. Grams are going to cancel in that case. The only unit we got left at this point is milligrams, which is on top, and that's good because that is what we're looking for. So math-wise, we're going to take 125. We're going to times it by really 10 to the 3. And we're then going to divide it by 10 to the minus 3. And if you do all that good stuff, you will get an answer on your calculator. And I'll just write down here because there's a lot of zeros. 1, 2, 5, and 1, 2, 3, 4, 5, 6 zeros, I think. 2, 3, 4, 5, 6 milligrams, right? Again, that's a lot of zeros, so we probably want to do a little scientific notation. This is going to give us something like 1.25 times 10 to the 8 milligrams. Again, milligrams is a very small unit, which means you have a lot of those small units in a bigger unit, right? So the number is bigger, so it does make sense. So again here, if you have a calculator that has that exponent button like we were talking about, the EE button, the EXP button, you can type it in most likely as 125 times. You do need to move to multiplication in this case because you are actually times in it. So 125 times the exponent button in 3, hit equals, divided by exponent button negative 3. Or you can do 125 times 1 exponent button 3 equals, divided by 1 exponent button negative 3 and hit equals, and you should get that answer. Question on those conversions there. And again, these are all these sort of conversions here are considered exact numbers. Don't have to worry about sig figs. And again, you can get an answer in between. All right. Now, if we're going kind of from English to metric here, we want to do some more conversions. May take you a couple more conversion factors. So try a couple more here. Here we're going pounds to grams, inches to millimeters, and then quarts to milliliters. There's some conversions on the right there that may be helpful for you in doing those. So take a couple minutes and then we'll talk about those. Again, set this up using dimensional analysis as you go through it. Okay, so let's see how we're doing on these then. Again, here we're going pounds to grams. So that is, again, a conversion that we've seen. So 1 pound is 453.6 grams. So we're going to use that as our conversion factor. So we're going to start with our 310 pounds. Again, pounds are on top, so we want pounds on the bottom here so that they cancel. 453.6 grams. Pounds will cancel in this case. Here we're going to multiply 310 times 453.6. 310 times 453.6. Going to give us 140,616 grams. In terms of sig figs here, we're looking back at our original number here, which has 2 significant figures. So again, here 2 would take us to here. We could go 140,000 grams, no decimal. So none of those zeros are significant. Or again, we could, we could scientific notation it at 1.4 times 10 to the 5th grams. Again, the 1.4 here being 2 sig figs or 2 sig figs here. Any questions on that one there? Next one, we're going from inches to millimeters. So we could use our conversion here where we have our 2.54 centimeters is 1 inch. And starting with our 75.2 inches, again, inches on top, so we want inches on the bottom. So 1 inch is our 2.54 centimeters. Again, here our inches will cancel if you like. At this point, you do have a couple of ways you could kind of go for it. But again, just to do it a little bit longer in terms of steps so you don't make any mistakes, you can use your centi conversion, and your centi being 10 to the minus 2. So that means, again, there would be 10 to the minus 2 meters in this case, and 1 centimeter, or 100 centimeters in a meter, whichever way you want to do it. Meters would go on top. Centimeters would go on the bottom so that they cancel. We are now left with meters in terms of our units. So our last conversion there, right, is taking it from meters to millimeters, and milli 10 to the minus 3.
Isn't it millimeters?
What's that?
It's millimeters, right, for the conversion?
It is.
That meters on top?
That's meters on top. We're not to meters. We're not to millimeters yet. We're to meters.
Okay.
Yeah, we're going to now take it from meters to millimeters. So again, now we could go from meters to millimeters, and that's 10 to the minus 3 for milli. That again means that there's 10 to the minus 3 meters in a millimeter. And again, you may want to again do this sort of, I don't want to call it extra step, but it's a more safer way of doing the conversion than trying to move decimal places and stuff like that. Again, you can clearly see now that the meters cancel. We're now left with millimeters there up on top. And in terms of math, we're going to take 75.2. Get my calculator go. 75.2 times 2.54 times 10 to the minus 2, which is again 1 times 10 to the minus 2 scientific notation in your calculator, divided by pretty much what we got on the bottom is 1 times 10 to the minus 3. And we will end up with 1910.08 millimeters. Again, in terms of sig figs, we're looking at 3 here. So that would take us to 1910 millimeters. Or again, you can do scientific notation if you want to in that particular case. Any questions on that? Again, a very safe approach here is to take it from one prefix unit to the base unit, and then back from the base unit to the next prefix unit. Again, it avoids a lot of miscalculations that happen in terms of zeros, decimal places, and stuff like that, or moving it over. Any questions on that particular one there?
Yeah,
Yeah.
I'm just sorry, I was lost back there. So how come we can't go from centimeters to millimeters?
You can if you know the conversion correctly, but I'll be honest with you, a lot of times people mess up on it.
Okay.
And again, moving it too many places one way or not enough places. And it's a very, very common sort of mistake that occurs. And the easy thing that you could do is a lot of times either you'll know the kind of conversion from the base unit to the prefix, those prefix sort of symbols, and it's really easy to find those conversions. And sometimes people kind of misestimate, moving it one way or another. And so it's a super common mistake. But you absolutely can, if you know the correct conversion to go directly, say from centimeters to millimeters, you could cut out that step. But a much probably safer way to do it is, again, going from that base unit. Other questions on that? All right, and lastly here, we're going from quarts to milliliters, and on yours there, you have quarts to liters. There is actually a direct conversion. Do you want the scientific notation on this one here? I'm assuming, yeah.
The last one that you used, Professor.
Yeah, that one, right? Right there.
Well, we compared the inches to millimeters.
Okay, so the answer in scientific notation would be 1.91 times 10 to the 123. Again, here we would drop that 0 in this one because if we kept it in that 0 in scientific notation, you would end up with 4 significant figures in that case. Yeah.
Got it. Thank you.
You're welcome. Other questions on that? Okay, so here we're going from quarts to milliliters, and there actually is a direct conversion that's very common, other than, say, this one, which is not necessarily a direct conversion. There's actually 946 milliliters in 1 quart. And in that case, we can use that if we like. 443.05 quarts is 1 quart, 946 milliliters. Again, the quarts will cancel. We will get 43.05 times 946. Again, giving us a big number here of 40725.3 on our calculator. This has 4 significant figures. So that 4 significant figures would take us to here. So 407, we would round 3. We do need to keep the 0, but no decimal if we're not going to do scientific notation on it. If we did scientific notation, I'll write it up here, 4.07 and 3 times 10 to the 1234 milliliters. Any questions on that one? This is the same conversion as was on your sheet there. It's 0.946 liters in 1 quart.
Professor, I actually have a question.
Yeah.
So for that one, I did quarts to liters and then liters to milliliters, and I got 40,613. So it's a close answer, but it's kind of off. So
you may get sometimes a different answer. Again, if you use the one that was there, let me just kind of punch it in, and I probably is what you just said there, 43.05. You then would have took you would have divided by 1 point. Getting old, but I think that says 0.6 on that, and that would get us to liters, and then there's 1,000 milliliters in a liter, right? And you would get 40613, right? So if you use the actual one that was on that sheet there, which I probably should have, you would have got the 40613 liters, and that would have been perfectly fine. You just want to round it to the right sig figs. And again, sometimes you'll find that depending on sort of what conversion factors that you choose, and also rounding that you choose along the way, you may come up with a slightly different answer. And it's okay, as long as whatever you use is sort of a legitimate conversion factor, it's okay in that sense. And again, there's multiple ways sometimes to do conversion problems, again, depending on sort of which conversion factor that you use. So if you use the one that was on here, which obviously you probably would have, you would have ended up with, in terms of sig fig wise, you probably should end up with 4061 milliliters, and that would have been okay. Our 4.061 times 10 to the 4 milliliters would have been okay as well. And again, you'll get a slightly different one depending on sort of your path that you choose and the conversion factors that you choose. Other questions on that? Okay. All right, so let's get this one here for now. Why don't you try this one again? It's the last minute edition. Why don't you give this one a go and see what you come up with in terms of answer. You're stranded 125 miles away from home. You're going to walk 55 feet per minute. How many days would it take you to get home? Now, give me a couple of things. There's 5,280 feet in a mile, right? And hopefully you know the rest. 60 seconds in a minute, 60 minutes in an hour, and 24 hours in a day. So see what you come up with. Okay. Let's take a look and see how we are doing. Okay, so we got a couple things. We have 125 miles, which is how far we want to go. We also have our rate, which is 55 feet per minute. So really, this is actually going to be our conversion factor. But we do have a problem. This is our length, right? And it's in miles. This is in feet. So we do have to convert it to the same unit, so everything will cancel out. So what I'm going to do is I'm going to first take my 125 miles and convert it into feet. Again, you could take the feet and convert it to miles, but they do need to be in the same units to cancel. And again, in 1 mile on the bottom, there's 5,280 feet. Miles will cancel. We're going to multiply 125 times 5,280, going to give us 660,000 feet. I'm not going to worry about sig figs at this point because I'm going to continue on with this number to do the next part of the calculation. Now that I have the distance I'm going in feet, I could use this as a conversion factor. So I could use it the way it's written. I could also flip it on its upside down and use it with the feet on the bottom. So we could kind of use this as our conversion factor. And basically what we're doing is really dividing by it, right? So we're taking 55 feet on the bottom per minute up on top. At this point, the feet would cancel. That's going to allow me to get into the unit of time, which is what I'm looking for, because we want to know how many days, right? So days is a unit of time of what we're looking for. So what we now need to do is go from minutes to days. And again, there's steps you could cut out of this or just kind of do it. One, there are 60 minutes in an hour. The minutes will cancel. And there are, again, only 24 hours in a day. The hours will cancel. We're left with days. And again, at this point, we're going to take our 660,000 divided by 55 and then divided by 24 and divided by 60 that I missed in the middle there. And we do get 8.33 days it would take me to walk home. Sig fig wise, both numbers that we got going on here, they're both 3 significant figures. So we would end up with 3 sig figs, as again, these guys here are exact numbers. We don't really have to worry about it. Since this is not a true conversion factor, you would probably want to look at this in terms of the sig figs if it happened to be, you know, something different like 2 significant figures or something like that. In this case, actually happened to be 3. Any questions on conversions, conversion factors, or anything like that there?
So how come you're able to just put the units on top with, so would that just be a 1 next to it? It's just not there?
Yeah, yeah. So
Okay.
I sometimes don't write it, but it is
Oh, okay.
it is
Yeah, I got
technically a 1. And,
Thank you.
And it's because typically when you have any type of units where there's something over something like, you know, say miles per hour, right? You know, miles per hour. You know, if you're going 60 miles per hour, you're driving, basically that means you're doing 60 miles in 1 hour. So usually the denominator is considered 1 in most cases when you have a fraction like this. Other questions on conversions? Okay, obviously you need to be able to do those. You need to know those conversions that we talked about along the way. All right, let's see here. And we're getting to the end. So why don't we stop here for today in terms of lecture, and we will break out in about 15 minutes for lab. Today we are going to finish up the first experiment from last time, the measurement ones, and then we're also going to watch the video for today's density one. We're going to talk about density at the beginning of lab, and so you have an idea of obviously what it is and that type of stuff, and we'll officially finish up lecturing on this chapter on Wednesday. So today, again, we're going to finish up the first experiment. We're going to actually watch the video and all that for the second one. And I'll let you know if the second one will be due today or not. But definitely the first one, the measurement one, will be due today. Now, in terms of links now from this point on, in terms of the links for the lecture and the labs, please only go to the module section and find the links and use those links. I'm going to not use the Confer Zoom section. If for some reason it's been really messing up the times and everything like that, even after I set it to the right times, it like changes it and stuff like that. So just go to the module sections for the links for both the lecture and lab from this point on. They will always be the correct ones, and you'll always have the right links that you need to get here. And so I'm going to sort of abandon putting them in there because for some reason it does weird things. It starts changing times and stuff like that. So that way you'll know everything's on the right time and the right link. So just go through those. If you didn't put here for the chat, please do so before you take off, and I'll see everybody in about 15 minutes. Go through the lab link in the module section.